Hello everyone, my name is Hanis. Today I will present my assignment titled Techniques of Differentiation. This presentation is part of my calculus course. In this presentation, I will explain what differentiation is, the techniques used in differentiation, and how to solve a differentiation problem step by step. Differentiation is a topic in calculus that focuses on rate of change. In simple words, it helps us understand how fast something is changing. For example, when distance changes with time, differentiation helps us find speed. That is why um, differentiation is very important in real life situations. So, what are the techniques of differentiation in calculus? First, we have basic differentiation rules, which contains four techniques. First, constant rule. Second, power rule. Third, constant multiple rule. And lastly is difference rule, or also known as sum rule. Next, chain rule, product rule, and quotient rule are for a lot more complex differentiation. Now, I will explain the basic techniques of differentiation used in calculus. First, we have the constant rule, which is on the upper left box. The constant rule states that when we differentiate a constant number, the answer is zero. This is because a constant value does not change. For example, if y equals 5, the derivative of y with respect to x is 0. Next is the power rule. The power rule is used when the function contains x raised to a power. The rule says that we multiply by the power and then subtract 1 from the power. For example, if y equals x cubed, the derivative is 3x squared. This rule is one of the most commonly used techniques in differentiation. Third, the constant multiple rule on the bottom left box is used when a function is multiplied by a constant number. According to this rule, the constant remains the same when differentiating. For example, if y equals 5x squared, the derivative is 10x. On the bottom right box, the sum and difference rule is used when a function contains addition or subtraction. We differentiate each term separately. For example, if y equals x squared plus 3x minus 4, the derivative is 2x plus 3.
For the next slide is some of the differentiation formulas, and this is some of the formula for tangent differentiation.
So now that we know the techniques of differentiation in calculus, we're going to solve a few problems. So here, this function is a product of two terms. So we use the product rule. After differentiating both terms, we obtain the final derivative. So the question is y equal to 9 e to the power of x tan bracket x negative 3 bracket. Here I wrote down the equation of product rule, which is dy over dx equal to u v prime plus v u prime. Um, so then we're going to use the let u equal to 9 e to the power of x, and then u prime equals to 9e to the power of x. Meanwhile, v equals to tan bracket x negative 3, and v prime equals to sec to the power of 2 bracket x negative 3 bracket. So the answer will be dy dx equal to 9 e to the power of x sec to the power of 2 bracket x negative 3 plus tan bracket x negative 3 9 e to the power of x. Next, we finalize the answer, uh, and it should be 9e to the power of x sec to the power of 2 bracket x negative 3 bracket plus 9e to the power of x tan bracket x negative 3. Moving on to the next question, which is y equal to x to the power of 2 plus 1 over sine x. Here I wrote down the quotient rules equation. Dy over dx equals to vu prime minus uv prime over v to the power of 2. Now the let u equals to x to the power of 2 plus 1. The u prime will be 2x, whereas for v equals to sine x, the v prime will be cos x. Now we're going to plug all of this stuff into the quotient rules equation just now, which will be dy over dx equal to sine x bracket 2x negative x to the power of 2 plus 1 cos x over sine to the power of 2x. And we're going to finalize the answer, which will be 2x sine x negative bracket x to the power of 2 plus 1 bracket cos x over sine to the power of 2x. So since this function is a fraction, we apply the quotient rule and simplify to get the derivative.
So for the final answer is going to be round off. So we have 1. So after that, we're going to put all the answers that we have into one big question. So Lx equals to Fa plus F prime A x minus A. So the x minus A, we have 0.02. So the L, which as we know, the x is going to be 8.02. So equals to 64 plus 191 over 12 times 0.02. So the final answer is going to be 62.32. So for the fourth question, fx is equals to x power of 3 minus 3 power of 1 over 3. So we have a equals to 8. So we substitute 8 to fx. So we have 8 power of 2 minus 8 power of 1 over 3. So the final answer is going to be 62. So we know that 8 power of 1 over 3 is equals to 2. So for f prime x is equals to 2x minus 1 over 3x power of negative 2 over 3. So we have x equals to 8. So the prime, so for the f prime, we substitute the x to 8. So we have 16 minus 1 over 3 times 8 power of negative 2 over 3. So so we have 8 1 over 3 is equals to 2. So for the 8 minus negative 2 over 3 is equals to 2 power of negative 2. So the final answer is going to be 1 over 4. So for the f prime 8 is equals to 16 minus 1 over 3 times 1 over 4. So the final answer is going to be 191 over 12. So so for the final answer is going to be round off. So we have 1. So after that, we're going to put all the answers that we have into one big question. So Lx equals to Fa plus F prime A x minus A. So the x minus A, we have 0.02. So the L, which as we know, the x is going to be 8.02. So equals to 64 plus 191 over 12 times 0.02. So the final answer is going to be 62.32.
In conclusion, differentiation helps us find the rate of change. By using the correct techniques of differentiation, we can solve calculus problems easily. These techniques are widely used in mathematics, science, and engineering.